April Fool.
This is the split term of the function x squared, to go into alpha square from beta square, the exact same way I want in G. This can be simplified, and replace alpha in place of beta to get upper bound, and replace beta in place of alpha to get lower bound. Because alpha is greater than beta. Now I'm trying to do the same thing I want in G, like increasing small increment in domain. I'm going from 0. Then a smaller increment epsilon square. Now this epsilon square is literally epsilon square minus 0, so this must be smaller than 2 epsilon into epsilon, and it is greater than 2 times 0 into epsilon. Next increment is epsilon 1 in domain, so in codomain, it is epsilon plus epsilon 1 square, minus epsilon square. And this is smaller than 2 times epsilon plus epsilon 1 into their difference, that is epsilon 1, and greater than 2 times epsilon into epsilon 1, and so on. In middle, all values cancel each and will remain only epsilon plus epsilon 1 up to epsilon n whole square, which is nothing but 1, because I know this function, but in G's case, I don't know enough about that function, so if I get something from this bounds, that will help my cause in G too. That's also if I found like these bounds in G. This upper bound is surely greater than 1, but how much greater is the question? It's difficult to calculate this value, because I don't know how epsilons are increasing. These are some random increments. Why do I need random increment? What if I increase values by which I know? Values I know here may not be known in G, so that's not good idea. Random increment also not good idea. What if increment values are same, that is all epsilons are equal? So it is increasing equally n times from 0 to 1. So the best value for all epsilons are 1 by n. Because this only will give 1, if I add all these epsilons. By applying this, it will become 1 by n, 2 by n, up to n by n in middle. Now so many things are common, if I take that out, it will be 1 plus 2 plus up to n, I know this value, it is n into n plus 1, divided by 2. So this upper bound is greater than 1, by a margin of 1 by n. N is also the count I choose. That means if I choose n larger, it will come closer to 1. Similarly for lower bound it is lesser than 1, by a margin 1 by n. This upper and lower bound just squeezes the value 1. I'm going to break G also like this. I need G values from 1 to 2, so the perfect way is by 1, 1 plus 1 by n, 1 plus 1 by n, plus 1 by n, which is 1 plus 2 by n, up to 1 plus n by n, that is 2. The general term will be like G of 1 plus m plus 1 by n minus G of 1 plus m by n. I need to find something for this to calculate its values. I name this term as B. B is a value contains G of something. G sees everything as a power something. If I want to see about that G, then I must raise that as a power of a. Because a power G of x is x. Also B is a subtraction of two G values. I can also see that as sum of two G values. I know how addition in power can be split. A power B can be split like this. Also negative power can be changed into positive by reciprocal them. Now this value is just what about what's inside G. After simplifying this I can notice that n will cancel out. And the numerator is just higher than denominator by 1, so if I divide this, it will become 1 plus something. Okay, what can I do next? It is in the form of a power b, but I need the value of b. Applying g will give us b. Okay, what's next? Previously b is in sum of two g's, now it's single g. Great improvement. What's next? Still I don't know. What should I do now? I think I got something. 1 plus 1 by something is lesser than a. No. Power also must be what's in 1 by something, but I got only 1 plus 1 by something. I missed something. What should I do? No worries, I'm going to put that on power. But left side was not looking good. A power b, whole power something, but I can make them as multiplies, because they said so. Now this will be lesser than a for sure. G is increasing, so applying g on both sides won't change the inequality. G only cares about what's on power of a, so b into n plus m is less than 1. Hence b is less than 1 by n plus m. Bingo! This complicated terms with g simply lesser than 1 by n plus m. Now I can easily calculate this. Wait, why should I calculate this? This is just greater than my complicated term. There are many things greater than this. Why this is so special? In function x square, both lesser than and greater than terms squeezes the requirement, so finding another term smaller than b will confirm my guess. That's also hidden somewhere. The turning point of finding greater 1 is identifying a power b is 1 plus 1 by something. That allowed me to get the greater 1. To get lesser 1, I need something like 1 minus 1 by something. First of all, how did I get 1 plus 1 by something? Once I get numerator is greater than denominator by 1, that made 1 plus 1 by something. To get 1 minus 1 by something, I need numerator is lesser than denominator by 1. But that's not possible. A coin is two sides, so does this 1 plus 1 by something. Previously I witnessed two weird things, both as numerator greater than denominator by 1, but one has plus 1 in numerator, another has minus 1 in denominator. That just blew my mind. Like this I need minus 1 in denominator. For that I must change my general term. I want m in place of m plus 1, so m will become m minus 1. But this is previous term of my general term, I want to discuss in this term. So I'm going to change my variable m into t. This will make sure that I will stay in this general term, just notation differs. This will just change into things I needed. By reciprocal this, I have to put negative 1 on power. This is exactly I needed. Now I can come back into m variable, because job done. Now I get something lesser than b. This also looks like squeezing my g. This has to be the real bingo. Now first term is g of 1, I know that value. Next g of 1 plus 1 by n, minus g of 1. Here m is 0. So greater value for this is 1 by n plus m. m0 will give 1 by n. Similarly for next term m is 1, so greater value is 1 by n plus 1. Up to the last term m is n minus 1, so the greater value is 1 by n plus n minus 1. That is 2n minus 1. Similarly I can get the lesser value terms. Now I can clearly see denominator is increasing by 1 to their next term, so I can simply write this as summation 1 by n plus m, where m goes from 0 to n minus 1, also for lesser terms. Now what's the guarantee that this squeezes g of 2? In x square function, lesser is 1 minus 1 by n, and greater is 1 plus 1 by n. So it squeezes 1 from left and right side. In fact, the lesser and greater values comes close to each other as n increases. That means the difference among them decreases as n increases. What's the difference here? Both lesser and greater value has same terms except 1 by n is present in greater terms, but not in lesser terms, and 1 by 2n is present in lesser terms, but not in greater terms. These are only differences on both terms. Subtracting this, I get 1 by 2n. So if I put n equals 5, then the difference between greater and lesser terms will be 1 by 10. So as n increases, these values come closer to each other, but still g of 2 will remain in the middle. So both these values gets closer to g of 2 as n increases. Now I'm going to put this in calculator for n equals 5. I don't have m in this calculator, so I have to put x in place of m. I get 0.7456 with more digits. I just need 5 digits only. To calculate lesser thing, I need to add 1 in denominator. This gives 0.6456. Greater has 0.7 and lesser has 0.6, otherwise all are same. I think I got 4 digits out of 5, only the second digit is in question. Also the difference between greater and lesser is 0.1, that is 1 by 10 as I expected, but only thing I know is g of 2 lie between these two numbers. How come I conclude that I got 4 digits? There are many numbers between these two. Only thing I can say here is g of 2 is lesser than 1, so the first digit is 0. So if I put n equals 50, the difference will be 0.01. I'm going to check that with calculator. Greater I got 0.6981. And lesser I got 0.6881. Exactly the difference is 0.01, so g of 2 will lie between these two. Also g of 2 greater than 0.6 and lesser than 0.699. Every number between this will have 0.6 at start, so first two digit of g of 2 is 0.6. Similarly, if I put n equals 500, then g of 2 lies between these two. So g of 2 is greater than 0.69 and lesser than 0.693. By this, first three digit of g of 2 is 0.69. Like this I need 2 more decimal places, so I'm going to put n equals 50,000. Hard-working calculator, it is adding 50,000 terms for me, that's why it takes this much long. Finally it arrived. Now I need to wait for arrival of lesser terms. Yes, first 5 digit of both these values are 0.6931. That's it.
ஏன் சிரிக்கிற?
உன்னை கூட்டிட்டு வர்றது உன் அண்ணன் நினைச்சியா?
உன் கூட வர்றது உன் தங்கச்சின்னு நினைச்சியா?